HVAC 360, episode number 46, Air Pressure Switches. Hey, welcome back, everybody, to another episode of HVAC 360. I'm your host, Matt Nelson. This week, we're going to be talking about air pressure switches. It's another control type of a device. But before I get into that, I want to take care of a couple of housekeeping items. I want to thank some people for writing some awfully nice things about me on the iTunes store, namely Nicholas and Jeff. I appreciate both of you. Those are very kind words, and I appreciate the ratings. If anybody else wants to, pen their comments, I'd be most appreciative of them as well. I'll give you a shout out on the show even. All right, so getting back to the air pressure switches, going through some of the control devices that you typically find in an air system. This is an air pressure switch. Sometimes they're known as a high limit switch or a low limit switch, or you can even use these type of devices on filters, dirty filters. So they come in a couple different types, and I'm going to focus on the one particular type that I see, all the time. So the three different types that I know about, and there might be others, but primarily you're going to have the most common, which I'm going to talk about, which is the diaphragm type. You're going to have a Bellows type of switch, and you're going to have a Borden tube. Borden tube, now the last one, that is actually mostly for gauges because it's actually a curved tube that as the pressure increases, it kind of straightens out. So you have some sort of mechanical lever arm and spring action that actually moves a gauge or a dial. So Bellows type, a little bit less common. Typically those are going to be, one side's going to be hooked up to a pressure side, and the other side is going to be atmospheric, so it's just going to expand and contract. But again, most of these are made for a simple contact. The diaphragm type, obviously, you have this kind of differential pressure that's either making or breaking a contact. So we're typically, again, I think that some of the optional features that we can talk about, and again, we're going to focus more on that diaphragm type, is you have some sort of auto reset, which I don't see all that often. Most common, you're going to have a manual reset, which, in essence, if you look at it, the diaphragm type, if you take a look at it, kind of looks like a thin deck of cards. And then you have a box, like a standard 2x2 box on top of it, some sort of electrical box on top of it that's going to have the working parts in there, and then you're going to have a little black button that pops out of that that's going to be the manual reset. So if it trips, you want to hit that, and then you're going to be back in business. So how does it work? Really, you got when you take a look at the main body of it, again, it's kind of this thinner metal piece, maybe like a half-inch thick. On the bottom of it, you're going to have two tubing connections. You can either hard pipe these, or I've seen a lot of them connected with plastic pipe, but you're going to have a high side and a low side. Now, that's probably, of all the things on this box, it's critical to know what's the high side and what's the low side, because if something's going to go wrong, that's really what you want to check. Typically, you're going to find either a high or a low, HILO, on the body itself, stamped into the body of the diaphragm, on the exterior casing, rather. So those are going to be the two primary ports. Now, you're going to also have a set screw in there when you take off the cover to that electrical box. So if you take off the cover that has that reset switch on it, there's going to be some sort of set screw. That's going to be what you're going to use to set your sensitivity to exactly what sort of pressure that you're going to allow it to trip at. So where do you find these in systems? Typically, it's going to be around the air handling unit. Typically, you're going to see it downstream of the supply fan or upstream of the return fan. Realistically, most of the time I see them on casings, but depending on the configuration of your ductwork or of your unit, you might actually see them slightly downstream. It might be just on the discharge ductwork. Anywhere that's downstream of the discharge on the supply fan is typically going to work. So again, you want to sense that pressure for the high limit. If it's going to be the high limit's going to be on the discharge side of the supply fan, the low limit's going to be on the suction side of the return fan. And of course, if you're going to measure the filters, have a dirty filter switch. Those are going to be around the filters. So most of these you would mount with the tubing towards the bottom. You're going to mount it vertically on the face, and the tubing's going to be towards the bottom. There's a couple of different ways that I've seen them penetrate the HVAC housing casing or the air handling unit casing. Typically, they're gonna drill them out. You might see the tubing just passing, kind of bare bones, naked through the casing, and they may caulk around it, or they should, because you want to make sure that it's a tight seal. Some others I've seen, recently, they've actually used some static pressure fittings that look real nice. So the static pressure fittings are these. I'm sure they come in a different variety of shapes, sizes, and colors. But the ones that I was looking at, these were brass fittings that just kind of screwed into the housing. So you connected the tubing on the one side, and on the other side, you connected the tubing to that. So they really looked nice. A lot of times you're going to have, if you take a look at the unit itself, the air pressure switch, the high limit, low limit. You're going to find one of the either the highs or the lows disconnected. It's going to be open to the atmosphere. And that's going to be your reference pressure to make sure that you get the right measurement. So similar to what you'd find in the diaphragm type. And obviously, it's, again, the high and the low, it's so easy to get confused. That's really what you want to check. Typically, obviously, it's going to be backwards sometimes. Other times, I've seen cases where the tubing was missing or not connected. It's not screwed on, it's not tight, or it's on the wrong side. Especially if you're looking at like a dirty filter switch, sometimes that can get kind of confusing. Exactly, where it lands. Sometimes it has to go through a filter frame to be on the right side. So you really have to take a close look at that. That's kind of, they put it in, they install it, and that's where they leave it off. Those are some of the things that they may not, and by they, I'm talking about the controls guys or whoever is installing the devices for them. Sometimes it might be the electrician. So, how do you test this? How do you set this? Clearly, you have the set screw in there, but how does one go about setting it? I mean, it doesn't really have a gauge inside. It's just a simple set screw. But what you want to do is you really want to, and I'm sure there's 1,001 different ways that you can do this. This is the one I've seen most common, where you pull out a magnehelic gauge. This is a gauge that measures pressure. It measures the appropriate pressure that you're trying to set it for. Obviously, you don't want to have something that you're trying to set it and it's not in range, or it's not the right scale. So you want to make sure that you get the right scale magnehelic. So you hook up your tubing, you get a little splitter, and you either use like a little hand pump, or you can even use just blow into the tube. So you can blow into the tube, have one side of the splitter go into the magnehelic, so you can measure the pressure there. The other side is going to go to the appropriate side of your switch. So when you blow into it, you're going to watch the gauge climb, and when it's this, where the set screw setting is, when it hits that setting, it's going to click off. So if you have the unit, you can do this while the unit's running, so you kind of replicate a real live type of application. So what you should do is disconnect the tubing, connect the magnehelic tubing, to the right side of the port, to the correct side of the port, and blow in there. Wherever it trips, that's exactly where it sets. The unit should shut down at that point, and then if you hit the reset switch, it should come back on. Obviously, you want to be able to take a little screwdriver and change the set screw so it closely closely matches what you're trying to set it for. And that's kind of the next question. Okay, now that you know how to set it, what do you set it for? Now, obviously, dirty filters are pretty obvious. You're going to set it for whatever you want the dirty filters to be set for, whether it be a half inch, 3/4 of an inch, some sort of static pressure drop that would indicate that the filters are dirty. This might be something that the maintenance staff might want to play with over time, depending on what they feel is dirty, what they see. That might be more of an experience-based thing. But the high and the low limit, those are pretty rigid. And what I mean by that is that the ductwork is going to have a specific pressure class that's going to be designed for. Now, what's a pressure class rating? Well, it's kind of a combination of the thickness of the metal, the gauge of the metal that the ductwork is constructed out of. However, it's been reinforced, the joints and the different sealants that are being used. And all that is kind of based on, at least here in the U.S., it's going to be based on SMACNA. It's the sheet metal manufacturers, or the sheet metal guys. So they have a guideline or a manual that'll tell you exactly, if you want this, this so many inches of static pressure, you're gonna make it, this thick of the metal gauge. You're gonna have it this, this type of reinforcing, this type of duct sealant, and things like that. International listeners, you can actually get, the SMACNA guide. I think it's available. If there's not something like that where of, ask around. It definitely is a good starting point for anybody looking to figure out exactly what the duct construction is. I'll put a link in the show notes for those of you who want to just at least take a look at it online. So now that you got the pressure class rating and you know what that is designed for, you want to set obviously the limit to less than that, just slightly less than that. You don't want to exceed it. Meeting it is probably a bad idea too. Really, I mean, what that means is basically if you meet or exceed the pressure class rating, there's a good chance that you're going to end up blowing out the ductwork. It's either going to explode or it's going to implode. I know on a couple occasions, there had been a case in construction where they had used they were run the units, and temporarily some damper linkage wasn't hooked up, and sometime during the night it slipped. Well, when it slipped, and this was on the return side, the plenum, that it was a built-up plenum, a constructed plenum, it just kind of imploded, and there was a lot of work that had to go into pushing it back out, reinforcing it, making sure that it was airtight again, and there's a lot of damage that can be done rather quickly if you don't have these devices on there. So again, it's really to protect the ductwork. These two devices. This is kind of why they exist. What their existence is. Really, in a constant speed system, if you're talking about a constant volume system, pretty quickly, whether or not it's doing its job, because typically, if you've exceeded the pressure class or it's not doing its job, it'll be known pretty very quickly whether or not you got it right. In a VAV system, it's a little bit different. Part of the reason why you want to do this is because the on the VAV, your VFD, your variable speed drive, isn't typically or isn't always sized at 100% of the load. So you have a little bit of room And this may be, in some cases, maybe in a retrofit application, it may be very significant, like you're taking it down quite a bit to reduce the airflow, based on a couple things that you've done in a retrofit application, or even on a new application, you leave yourself a little bit of slack there at the end of the motor. So if you wanted more air, you can get more air, but that still leaves more power there if something goes wrong. And typically, what you're gonna find is that sometimes if the VFD goes bad, you're gonna override it, and that the override takes it to 100%. So that's kind of one scenario. A couple different other scenarios that happen is that if you return, like I was saying, if some dampers close on the return side, then you get some blockage, essentially blockage in the airflow in the ductwork, and that's going to really play havoc on it. If you have a fire damper somewhere downstream, that could be an indication. Especially if the static pressure sensor that you're running your VFD on is downstream of that, so it's in between the fan and the pressure sensor. That's going to kind of isolate the pressure sensor and not necessarily allow it to operate properly. So if the fire damper shuts, and you start building up static pressure, and you just don't know, because that's your fan. The only thing your fan knows is what the static pressure is, downstream of that fire damper. It's going to blow out the ductwork. So you have the high limit there to trip it, to make sure that it's safe. And a lot of times, if you rely on the static pressure sensor, say everything goes normally to plan, for instance, in the case where you're reading the static pressure sensor, sometimes your VFD is not going to react that fast, that you're kind of exceeding that set point. So the high limit and the low limit, they provide a quick response to a change in the static pressure, just to protect that ductwork. Because I guess not only is it going to be, an explosion, essentially, in the ductwork, that could also have some sort of other ramifications, whether or not it hit conduit, causing shorts, other things. A lot of damage can happen because of a ductwork exceeding its pressure class. So those are some of the things that I think about when we talk about high limit or different air pressure switches. So I hope that was helpful. I know it was kind of a brief discussion today, but I just wanted to throw that out there and get something to you, get you more to chew on. So appreciate each and every one of you. I think it's really great. You are leaders in the industry. So thank you for listening. I appreciate each and every one of you. If you have any show suggestions, I'm always receptive to those. You can give me a holler. My email is matt@buildingx.co. Or if you want to follow me on Twitter, I don't post a lot, but if you want to follow me on Twitter, sometimes I do, you can follow me @buildingx. Otherwise, if on LinkedIn you want to connect with me professionally, I'll be more than happy to do that. Just send me a request, and we can get that going. And otherwise, if you want to know some of the behind-the-scenes details and a little bit more, you could sign up for the Building X newsletter right at buildingx.co. So until next time, remember, know what you build and share what you know.